Today we have an example of a problem to apply what we learned about buoyancy in physics. So we have a body of a mass of 0.2 kilograms and its density is 4,000 kilograms per cubic meter, and this body is submerged in a liquid with a density of 800 kilograms per cubic meter, and we need to calculate the apparent mass of this body. So we start with, we can drawing makes physics easier, I think. So we have our liquid and its density is 800 kilograms per cubic meter, and this is the body. It's totally submerged in the liquid, and the density of the body is 4,000 kilograms per cubic meter. So we have here two forces. A force that pulls the body down, which is the weight of the body, so F. Let's say Fg. And another force that pushes that body up, which is the force of buoyancy, so Fb. And we have the apparent mass. We will call it Fa. And that force, that apparent weight, equals the force that pulls the body down minus the force that actually pulls the body up. So this is the apparent mass. So let's start to fill the gaps here. The force that pulls the body down is the weight of the body, and the weight equals the mass multiplied by gravity. We will say that gravity equals 10 meters per square second. So we have here this Fg will equal 0.2 multiplied by 10. 0.2 kilograms multiplied by 10 meters per cubic or per square second, minus, and then we have the force of buoyancy. The force of buoyancy equals the volume of the object, so the volume of the object multiplied by the density of the liquid multiplied by gravity. So here, this is the volume of the object or the body, and the density of the liquid multiplied by gravity. So this will equal 2 minus, here we have the volume of the body. We don't have it directly here, but we have the mass and we have the density. We know that the density equals the volume, or the mass, the density, if anything, equals the mass divided by the volume. So the volume will equal the mass divided by the density. So we have the mass, 0.2, divided by the density, which is 4,000. And then we multiply this by the density of the liquid, which is 800, and multiplied by gravity, which is 10 meters per square second. So this will equal 2 minus, here we have all the zeros will be cancelled. We have 8 multiplied by 0.2 is 1.6. 1.6 divided by 4, which is 2 minus 16 divided by 40 is 4/10, which is 0.2 4, so we will have 1.6. So 1.6 newtons. This is the apparent weight, but we don't want the apparent weight, we need the apparent mass. So we know that the weight F equals mg, the mass multiplied by the gravity. So the mass, this will equal 1.6 divided by 10, which gives us 0.16 kilograms. And this is the apparent mass of the object. So this is how we use the buoyancy in order to solve such problems. I hope it was easy for you, and until the next time, I thank you for watching and see you.